We use it every single day, right? To find a coffee shop, navigate a city you've never been to, or even just check how far you went on your morning run. It's just that little blue dot on our screen, and honestly, it feels like pure magic. But have you ever really stopped to think about it? How does your phone actually know, down to the foot, exactly where you are on this giant planet?
I mean, really think about that. How does this little device in your pocket talk to something that's orbiting thousands of miles above your head just to tell you that you're standing right here, right now? Well, the answer is this brilliant, beautiful combination of physics, engineering, and some incredibly precise timing.
So, to crack this, the first piece of this incredible puzzle doesn't start here on Earth. Nope. It starts thousands of miles up, with a constant stream of information basically raining down on us from orbit. Now, we're not just talking about one satellite. The Global Positioning System is actually a whole constellation, like a team of at least 24 satellites, all working in perfect sync. And each one is constantly just broadcasting a simple radio signal down towards Earth, blanketing the entire planet in this invisible grid of information.
Okay, so what's in that signal? What's the secret sauce that unlocks our location? To figure that out, we need to zoom right into the heart of each satellite, where we'll find its single most important piece of tech. And here it is, the atomic clock. Now, this is not your average wristwatch, okay? We're talking about a device so ridiculously precise, it won't gain or lose a second in millions of years. This crazy accuracy isn't just for show either. It is the absolute foundation that makes GPS possible. Because think about it, when you're dealing with signals moving at the speed of light, being off by just 1/1000th of a second could throw your location off by nearly a foot.
It's kind of amazing when you break it down. The main job of a multi-million-dollar GPS satellite is to basically just shout the time out into space, over and over and over again. It sends out a signal that just says, hey, the exact time I was sent was this precise moment. So the moment that signal leaves the satellite, a race begins. It's a race between that signal, which is traveling at the speed of light, and the, well, much less precise clock inside your phone. We already know who wins, of course, but it's that tiny, almost infinitesimal time difference that holds the key to everything.
Okay, so here's how your phone does the math. The satellite sends its timestamp signal. A fraction of a second later, bam, your phone catches it. Your phone then looks at the time the signal was sent and compares it to the time it was received. That tiny, tiny delay, that's the signal's travel time. And since we know exactly how fast that signal was moving, the speed of light, your phone can instantly calculate how far away it is from that one satellite. Pretty cool, right?
But here's the thing. Knowing your distance from just one satellite isn't quite enough. I mean, that just tells you you're somewhere on the surface of a giant imaginary sphere, with the satellite sitting right in the middle. To find your exact spot on that sphere, your phone needs way more data points. Yeah, so if you only hear from one satellite, you could be anywhere on this huge sphere. But add a signal from a second satellite, and now you have two of those giant spheres overlapping. And where they intersect, that narrows down your possible location to a perfect circle. We're getting closer.
And believe it or not, this super clever geometric trick of using overlapping spheres to pinpoint a location, it actually has a name. It's called trilateration. And that is the core mathematical principle that turns these simple distance calculations into a precise dot on a map.
So, a third satellite. That's the real magic number. The sphere from that third satellite will intersect the circle made by the first two at exactly one point on the Earth's surface. And boom, that's your latitude and longitude. And just for good measure, your phone usually listens for a fourth satellite. That one helps confirm all the data, and crucially, it also calculates your altitude, how high up you are. So after all of that, all that cosmic calculation, signals flying from space, atomic clocks ticking away, all these geometric spheres overlapping in the sky, it all comes together in one beautifully simple, elegant result. This, a clean, simple set of coordinates. 40.7128 degrees north, 74.0060 degrees west. All of that complex physics and engineering happening in literally a split second, just to generate these two numbers that tell your mapping app exactly where you are standing. And that's really it. That's the powerful little formula at the heart of the whole thing. The signal from a satellite plus incredibly precise time gives us distance. And with enough of those distances, we get your exact location. And that leaves us with one final, kind of mind-bending thought. This entire system depends on time being perfectly, absolutely constant. But what if it's not?
Einstein's theory of relativity proved that time actually runs a tiny bit faster for the satellites up in orbit than it does for us down here on Earth. And without correcting for that tiny difference, the whole GPS system would fail in just a few minutes. But how they solved that? Well, that's a story for another explainer.